What could cause the mysterious dancing Keshiki light phenomenon that slips across coastal fog and mountain ridges, baffling scientists and thrilling local storytellers? For generations, fishermen and hikers have reported shimmering ribbons of light that twist and pulse above the horizon. Refusing easy explanation and inviting folklore to fill the gaps, eyewitness accounts describe colors that shift like oil on water, patterns that mimic living movement, and a sense that the lights respond to observers rather than drifting aimlessly. Early theories ranged from atmospheric reflections and ball lightning to bioluminescent swarms, but none fully matched the phenomenon's scale, persistence, and occasional synchrony with geomagnetic activity. Modern researchers armed with cameras and spectrometers have recorded spectra, timings, and weather correlations that point toward complex interactions between charged particles, moisture, and topography. Some data suggests that ionized layers in the lower atmosphere can refract and modulate distant light sources, creating illusions of motion amplified by wind shear and temperature inversion layers. Other studies emphasize the role of tiny airborne particles and electrical discharges that can generate flickering coronas and structured luminous filaments under specific conditions. The Keshiki Lights' elusive character is partly cultural, since local names and stories shape how observers watch and report, producing a fascinating blend of science and myth. Documentary footage shows repeatable sequences where lights pause, accelerate, and form curves resembling dancers, which challenges purely random or mechanical explanations. Citizen science projects now invite hikers to log sightings with GPS, weather data, and smartphone spectrometry, creating datasets that help separate rare phenomena from misperception. Yet still, key questions remain about energy sources, whether minor seismic activity or solar wind bursts play a part, and how human attention might subtly alter visible behavior. Researchers have replicated microscale luminous filaments in the lab using controlled plasma pulses, hinting that small-scale electrical phenomena can scale up under right atmospheric conditions. Interdisciplinary teams are combining satellite auroral data, local magnetometer readings, and long-exposure imaging to map occurrences and test correlations with solar and terrestrial activity. Local elders often recall these lights appearing before important storms or strange tides. An oral archive that offers temporal markers scientists can compare with instrumental records. Now, the term Keshiki itself means scenery in Japanese, capturing how the lights are woven into place-based narratives and reminding researchers to respect cultural context. The mystery of the dancing Keshiki lights endures because every answer opens new puzzles, pushing researchers to combine fieldwork, laboratory plasma experiments, and indigenous knowledge. Whatever the cause, the phenomenon reminds us that the natural world still contains spectacles that resist easy categorization and reward curiosity, patience, and careful observation. If you enjoyed this exploration, please subscribe to the channel and like the video.